We have much vocab to go over today for similar figures. So the first is image versus pre-image. Okay. Pre-image is the original image or original figure that you're graphing. And then the image is the transformation of the pre-image. So we can apply this to shapes or points on a graph. So the original point that was graphed was the point A, and then the image shape that was graphed or transformed, we reflected it over the y-axis to graph in a new location on the coordinate plane. The way we denote that we have an image versus a pre-image is that an image has just a plain variable, so A, and a pre-image would have a prime on it, which is that little apostrophe, okay, the prime. So we'd say A prime, or F prime, okay, prime. All right, congruent is when two shapes are the same size and shape. So that means that all of the angles and all of the side lengths are the same. So congruent means same or equal value. And then it means that all of the angles and all of the sides are of equal value to each other. So we denote congruent sides by putting in these little tick marks. So the tick mark on one tick mark, AB, is congruent to ED. Sorry, DE. So we do A, we're going to start with B actually. BA, the length BA, is congruent to is equal to ED. Okay, E to D. All right, so DF would be congruent to, we look for two tick marks, AC. So DF is congruent to AC. Okay, the three tick marks means that it is congruent to the other length that has three tick marks. Same with the angles. Angle A is congruent with angle D because they both have two arc marks. Angle C is congruent with angle F, and angle E is congruent with angle B. All right. Sometimes we mark the angles as like an actual measure. So 92 degrees, angle P is congruent to angle N. Okay. And the way we actually write angles is with three vertices. So we say RPQ, so angle RPQ is congruent to, and R is between the one tick mark and three tick mark sides, so we start with M, congruent to M and Q. Oops, wrong direction. We have to keep it, yeah, N, M, and Q. Whoa, had a moment there. Okay, so the angle, the letter in the middle is really the angle that we are measuring. Okay, it just tells us which direction we're counting the angle. I forgot one thing. When we say congruent, we usually put the congruent symbol is an equal sign with the squiggle line on top. Okay, it means equal value. All right, scale factor. Scale factor we get by comparing two proportional figures. So meaning that they are dilated or every side is multiplied by the same number to get from one figure to the next. So to get our scale factor, we're going to call the triangle on the right the image, and the triangle on the left the pre-image. So that actually means that the triangle on the right is the original, and the triangle on the left is the new triangle. So what we do is we have to take corresponding sides. So I'm going to take side ST, and it's the hypotenuse of the triangle, and I'm going to divide it. I'm going to take the and put it underneath. So we do the scale factor is equal to the image value over the pre-image value. So I'm going to take 15 as the pre-image, so it goes in the denominator, and then 10 is in the numerator. We reduce that to, we divide out 5 on the top and the bottom, giving us 2 over 3. So the scale factor is the triangle PRQ is 2/3 the size of triangle SUT. So when I get the scale factor for every side, so let's go ahead and do UT and RQ. We would do image over pre-image values, giving us 6 over 9. I see we can divide out a 3 on the top and the bottom, giving us a ratio of 2/3. Again, our Q's side length is 2/3 the size of UT's side length. Okay, lastly, we're going to do PR to SU. So PR is the image over the pre-image, giving us 8. So 8 over 12. Divide by 4 on the top and the bottom, giving us 2 over 3. Notice every single side has the same scale factor. If they are different scale factors, then the images are not proportional. Okay. One thing to keep in mind is that if your scale factor is greater than 1, so like 1.1 or 7 or pi or 1.01, then the image grows. The image stretches. Okay. If your scale factor is between 0 and 1, so like example 1/2, 0.1, 0.9, 0.8, 7 over 12, then the image shrinks. If your scale factor is exactly 1, the image is the same size as the pre-image. Okay. So something to remember about similar figures is that all of the side lengths are proportional. Okay. So the side lengths are proportional. Oops, looking for the highlighter. And the angles are congruent. So if you notice, the angles don't change sizes, only the side lengths. So I have the angle measures are 60, 30, and 90. So when I go and look at the smaller triangle on the right, I have 60, 30, and 90. The side lengths are proportional to each other. So I can see that if we call this the image and this the pre-image, oh, let's switch it this time. Let's do, since it's not defined, we can decide which way we want to go. So the pre-image to the image, is the image shrinking or growing? It is shrinking. So then the scale factor is going to be a fraction that is between 0 and 1. So I take to get my scale factor, I do my image over my pre-image length. So I can do 3 over 9. Okay, we have to choose the sides. So this side length is between 60 and 90 degrees. So I have to choose the side length that's also between 60 and 90 degrees. All right, this should equal the side length between, the ratio of the side lengths between 60 and 30. So 60 and 30. Okay, my image is 5. My pre-image is a length of 15. Okay, lastly, between 30 and 90 for the image will be 4. And between 30 and 90 degrees, that side length is 12. Okay, all of these reduce to 1/3. They are the same, so the triangles are proportional. All right, so we're going to determine if the figures are similar. So that means that the sides are proportional and the angles are congruent. So we just need to test to see if the sides are the same, or the angles are the same and the side lengths are proportional. So I'm going to look at the first example. I see that angle A and angle D match, angle B and angle E match, and angle F and C match. So the three angles are congruent. So that's one thing I have to look for. Let me say that's check. Now we have to make sure that the three sets of sides are proportional, aka they have the same scale factor. Okay, so we're going to test. We always have to choose the same sides from the different triangles. So between angle A and angle B is a side length. We're going to call this the image and the pre-image. Okay, between D and E, those sides are corresponding. So I have 6/9. We're going to hopefully say that that is congruent to, or proportional to, BC is from the image. We'll do image over pre-image. So a length of 4/6. And then lastly, a length of 3/4.5. And you can do this in your calculator. Honestly, you can do this in your calculator. Okay. I get that this is a length of point. So if I divide 6 divided by 9, that's 0.6 bar, or 2/3. And this one would be 0.6 bar. And this one is also 0.6 bar. I can also do this by dividing 3 out of the top and bottom. Out of the middle, I can divide out 2. And out of this one, I can divide out 1.5. That one's a little tricky. Okay, giving me a ratio of 2/3. 4 divided by 2 is 2. 6 divided by 2 is 3. 3 divided by 1.5 is 2. 4.5 divided by 1.5 is 3. Notice the scale factors are proportional, or they're the same. The scale factors are the same. So because we met both of these conditions, the triangles are proportional. Okay. All right, so you try. So we're checking 3 angles congruent. Are 3 angles congruent? And are 3 sets of sides proportional? How about the ratios of 3 sets of sides? Okay. So it looks like we have angle A and angle D are congruent. So that's one angle. Angle B and angle E are congruent. That's 2. Angle F and angle C are congruent. All right, so we have three angles that are congruent. Now we have to see if the ratios of 3 sets of sides are proportional. So again, I'm going to start with A to B. Since that line is between the 1 tick mark and the 2 tick mark angle, see the 1 tick mark and the 2 tick mark angle, I'm going to say that is, so we're going to do image over pre-image. Okay, so 10/20 is equal to, okay, between the 2 tick mark angle and the 3 tick mark angle, so 5 over, let's see, E to F, that's the 2 tick mark angle to the 3 tick mark angle, 13, okay? And then we have between the 3 tick mark angle and the 1 tick mark angle, so the lengths, I have 7 over 14. Okay, so 10 divided by 10 and 10 divided by 20, or 20 divided by 10 is 1/2. 1/2. I'm going to move on to the blue. 7 divided by 7 and 14 divided by 7, those both go in. So that is 1/2. It looks like I don't have anything that divides out of 5 and 13, so I have 5 over 13. All right, when I go ahead and type these into my calculator to get a decimal, I get 0.5. 5 over 13 is a long decimal, 0.384. It goes on forever, so I'm going to put dot, dot, dot. And then this last fraction is also 0.5. Okay. So the 3 sets of sides are not proportional. So we don't have this. All the scale factors are not the same. So the scale factors are not the same. So the triangles are not proportional. Okay, and which means that they are and not similar. So when the triangles are proportional, then they are also similar. The side lengths of the triangles are proportional. Okay. All right. So okay, we just filled in that sentence above. Okay. All right, so the TV screens. I want you guys to tell me if these two rectangular TV screens are proportional. The angles for the TV screens are 90 degrees, so every angle here is 90 degrees. Otherwise, you're going to have one weird wonky TV. Okay, so all the angles are congruent already, so we can say the angles are congruent. Okay, so the TV screens have the same angles. We need that, okay? And then we have to test the sides. So are the sides proportional? Or in other words, have the same scale factor. So luckily I only have 2 sets of sides to test. I only need to test the top to the top versus the height to the height. Okay, so let's do, this is our image and our pre-image. Old TV, oh, old TV. Whoa, old TV would be pre-image to image. It's the new, remember, is the image. So I'm going to do the image over the pre-image. The height would be 5 over 9. And we're going to see, is that equal to 20 over 16? And I'm just going to type these into my calculator to get a decimal. So 5 divided by 9 is 0.5 bar. It goes on forever. And 20 over 16 would be 1.25. Are these scale factors the same? No. So then we would say the sides are not proportional, so the figures are not similar. Okay. I put in triangles, that should be TV screens. Okay, next up. We're going to say that these side lengths these figures are similar. So remember, that means that they have the same angles and they have proportional sides. So I'm going to solve to figure out the rest of the side lengths in my figures. Okay, so it looks like I have a clue in, I'm going to call A is the pre-image and B is the image. So I'm going to start by saying that the image, this length 2 over 5, because the side lengths have 2 defined numbers, I'm going to use those because they're going to help me solve for the rest of the side lengths. Okay, so I'm looking for a set of side lengths that have actual values. So I do image over pre-image. I'm just going to write that over here so I don't forget. I do 5 over 2. Okay, and that should equal the value of the top part, the width of the rectangle, over the other width, because if the rectangles are similar, then the side length should also be proportional. So I'm going to do 7.5 over x. To solve for x, we have some different options here. First, we're going to use, what I did was I set up a proportion, which is two equal fractions. So these fractions are equal to each other, they just haven't been reduced. I'm going to cross multiply. I can only cross multiply when I have an equal sign in between. Okay, so 7.5 times 2 is 15, and then 5 times x is 5x. Next, I divide both sides by 5 to get x by itself, giving me a side length of 3. So I go over to my image and I say that the pre-image length would be a length of 3. I notice that the 5 is the same as the other 5, so the height. So the y value is also going to be 2, since the two sides are congruent. Okay. The top and the bottom of my rectangle are congruent. So on the smaller rectangle, the top and the bottom should also be congruent. So z is going to equal 3. All right. Another way to do this is to set up our scale factor. So it is image over pre-image. So we're just going to use our 5 over 2. Okay. And we can get a decimal, that's 2.5. You just need to make sure you don't round your decimal, so you have to store all the values in your calculator. What we do is we take the length of the image over the pre-image. So what I'm going to do is take the pre-image length, okay, times the scale factor to give me the image length. So we always do this. So the pre-image length was x. We didn't know what it was yet. Our scale factor, this is our scale factor, is 2.5, and we got out a length of 7.5. Okay, so we did something to the original to give me 7.5. I'm going to divide both sides by 2.5, giving me x is equal to 3. So we just solved for the length of our missing side. All right, let's do another one. So we'll do it both ways. So image over pre-image, I'm looking for two sides that have, it looks like, okay, so I can see that the 4 and the 28 come from the same length, and the 21 and the 3 come from the same length. This was a little hard to tell. The 12 and the 84 come from the same length. And then let's change to blue. The X length is the same, would correspond with the 91. What we're going to do is set up a scale factor. So I have 4 over 28. So 4, this is our image and our pre-image. You can switch them if you want and it'll still work, okay? So 4 over 28, and this is how I'm going to test to make sure I have all the correct coordinating sides, is I am then going to take my yellow sides, 12 over 84, and my blue sides, 3 over 21, and I'm going to make sure that these are all the same. I'm going to type them into my calculator. 4 over 28 is 0.1425. 12 over 84 is 0.14. 3 over 21 is 0.14. So I know that I matched up the right sides with each other. If I didn't get the same scale factors here, then I would have to figure out which sides to divide so that I do get the same scale factors. Okay, so I'm going to use any one of these three scale factors. Okay, I'm going to use the 3 over 21 because that's the one that's driving with me. And then I set up my unknown, which is my x is my image over my 91 from the pre-image. Okay, cross multiply. I get 21x is equal to 3 times 91, which is 273. Then divide both sides by 21. So I get 13. So my x value is 13. Okay. So another way to do this is to say that, remember, we're going to take the pre-image times the scale factor is equal to the image. So I'm going to take 21 is the pre-image length, multiply it by any one of these fractions. So let's do 12 over 84 is equal to the image length. So this is 21 over 1, so I do 21 times 12 over 1 times 84 is equal to the image length. So 21 times 12 divided by 84, my image length is 3. And you can see it's 3 because what I did was I took the green and multiplied by the scale factor to give me the blue here. Okay, so what I did was multiplied the 21 to give me the 3. Now what I want to do is multiply the side 91 to give me my transform side. Okay, so I'm going to set this up. So I was just testing to make sure that this works. So pre-image times the scale factor is equal to the image. So I have 91 was my pre-image length times the scale factor of 12 over 84 is equal to the image length. I get 91 times 12 over 84 is equal to the image. Okay, so I have 91 times 12 over 84. So I get the image length is equal to 13. Matchy, 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 matchy. Okay, last one. We got to test to see since we already know these shapes are proportional, we got to figure out which sides are proportional with, relate to one another. Okay, so I think that it looks like the 4 and the 52 go together. The shorter side here, 7 and 91 go together. And then the 7 and the other 91. Okay, and then so we're going to test. We're going to be like, let's start with the blue. That's the pre-image and the image. Okay, so image over pre-image. I'm going to do 91 in the blue over 7. Okay, the purple length is 91 over 7, and the yellow length is 52 over 4. We divide those. 91 over 7 is 13. Okay, so I have 13. I can see the second fraction is also 13, and then 52 over 4 is 13. So check, it looks like my scale factor is equal to 13, or any of these are also your scale factor because they're all equivalent. So I'm going to start with 52 over 4 as my scale factor is equal to, okay, it should be proportional to, and I'm going to use my image over my pre-image. Sorry, yeah, image over my pre-image. So I have x over 11. Okay, to solve for x, we cross multiply. Again, we can only do that because we have an equal sign in the middle. So 4x is equal to 52 times, 52 times 11 is 572. Divide both sides by 4. And I totally am using my calculator for some of these calculations. Right? Divided by 4 is 143. So x is a length of 143. What we're saying with the scale factor is that 7 times 13 will give me 91. 11 times 13 will give me 143. 4 times 13 will give me 52. So let's go ahead and work on our scale factor method. We're going to start with our pre-image length, multiply it by the scale factor to give us our image. So the pre-image length that we're testing is 11. We are saying that the shape stretches by times 13 to give us our image length. Okay, so 11 times 13 is 143. So it's 13 times larger. Okay, that was a long one, but we're done.